Hello everyone, welcome back to another remote sensing lecture video. In this lecture video I want to talk about the third type of errors that can impact the accuracy of change detection. And these are map errors. And again, map errors impact map to map change detection. We're comparing the classification results of one map to the classification results of another, and we're trying to see where change occurred and potentially what kind of change occurred. So if you remember our previous video, we talked about classification scheme errors, which was the idea that the definitions of the classes could arise to change being detected where there wasn't change. And we went through the example of a swimming pool where you had one classification scheme saying it was water and another scheme saying that it wasn't. And so when you compared them, even if the swimming pool hadn't gone anywhere, you would still get change. Map errors deal with the actual classification accuracy. So this deals with classification accuracy. Right? And so if you remember back to our discussion on classification accuracy, right, we sort of made this whole module talking about the fact that classifications aren't perfect, right? There's always going to be some underlying errors where a pixel is called one class when it's actually another, right? And so you can imagine doing change detection, right? That's going to cause problems. And so I don't think we're going to do too many diagrams here. Oh, maybe we will. Maybe we will. So let's just do a quick diagram to explain what we're talking about here. So let's go ahead and do a quick we'll do a 4-pixel image, or 4-pixel map, right? And we'll say that we have, this is the real world. We'll say we have water, forest, and urban, right? So this is the real world. And we're going to say that no change occurred. Right? We're going to say no change occurred. Right? No change occurred between the two time periods. We're just going to make this statement again. This is a hypothetical example. Right? No change occurred. So let's say at time 1, right, our classification accuracy was 75%. And let's say that it misclassified the forest pixel right here, that it misclassified that as urban. So this pixel was wrong in time 1. Right, so just to clarify here, this pixel misclassified. Right, this pixel was wrong in time 1. Okay, so just to make sure everyone understands, this would be a classification error. This would be a map error. This would be one of those pixels, right, that would go in the not correct class. So then let's compare that at time 2. Right, so time 2, we run a classification. We keep the same classification scheme, so we have no differences in definitions here, right? We're assuming the definitions are the same, so any issues we see come from the accuracy of the classifications, not the definitions that we used. Okay, and let's say that this time it actually got it right. Actually, let's say this time, yeah, say this time it got it right. That it actually classified everything correctly, and that we got our pixels. Right. So this is 100%. Now, granted, this is an unrealistic expectation, right? You're never going to have 100% accuracy. But for the sake of our example here, let's say that this was perfect. Right? So the real world, again, water, forest, urban. we're saying for the sake of argument here that no change actually occurred, right? That this stayed consistent between time 1 and time 2. Time 1, there was an issue and this pixel got misclassified. So right, time 1, this is calling it urban, when in the real world it was supposed to be forest. Time 2, it got it right. So now we compare. Slide down a little bit. So let's go ahead and compare. Right. So let's go ahead and do our change, no change. So green is going to be change, and red in this case is going to be no change. Right. So this pixel compared to this pixel, again, we're just doing that map to map classification change detection. Right, this pixel to this pixel, water and water, no change. Right, this pixel to this pixel, right, forest compared to forest, again, no change. This pixel to this pixel, right, urban compared to urban, again, no change. What happens up here though? Right, this was urban at time 1 and it was forest at time 2. So we actually are saying that there was change. So this would be change. Okay? But let's think for a second. Right? We already said, according to the real world, that this pixel was supposed to be forest. And we said that no change has occurred, right? In our hypothetical example, right? We're saying that no change has occurred. But we measured change here. So this is an error. Right? And the reason it's an error, right, the reason we're detecting change here, even though we know, in quotes, right, that no change occurred, is because this was a classification error. Right? This was a misclassified pixel in the classification at time 1. So this should have been forest, but the classifier called it urban, and it got used, it got compared, and it came out as change, even though no change actually occurred. So hopefully that makes sense. Again, classification map errors are dealing with the fact when you have a classification error in one of the maps that highlights things as change when there hasn't been. Right? And again, in this example, time 1 had a classification error here where it called it urban when it was supposed to be forest. Time 2 was correct, and so we get an error here. So hopefully that makes sense, and if you have any questions, please reach out. Thank you.